This lesson, Integration with Other Environments, covers both network edge configuration for users and clients and network connections to other networks such as data center or another cloud environment.
So first of all, we have our external IP addresses. Now, we do offer external IPs that you can assign to virtual machines, but it really kind of goes against best practices. Since you're only allowed 7 static IP addresses per project, we recommend you put those on a load balancer. Now, if you're doing a network or an internal load balancer, you're going to get any external IP that you can use, but we have a reserve set of global IP addresses available to you. Now, these are available only for our global load balancers, and that's because we've configured BGP routes so that way they're announced at every single POP in the world. So basically, your customers will enter the Google network as soon within, say, 250 to 500 miles of any major location or any major city in the world. And that's going to be a huge benefit because our networks are far superior than what you're going to find on the public internet itself. And also notice that you will get a global IP address that cannot be assigned to regional or zonal resources. This will be a specific range, which also makes setting up DNS and firewall rules much easier because you can now isolate and say, I only want traffic from this range, which are external Google IP addresses, to access any virtual machines or internal services. Now, Cloud CDN is also another fantastic alternative. The reason here is this uses our globally distributed edge of points of forgive me there. It uses our distributed edge points of presence. So here, let me take a look at this. So if you go to cloud.google, actually no, if you go to peering.google.com, and there's a really kind of cool visualization. So let's go here under Understand Our Infrastructure, scroll down to the bottom, and our CDN encompasses this particular map here. So if you make this full screen, you're going to see all these little dots. And what that will do is kind of signify all the little edge points of presence we have around the world. Now, these are all caching locations. And so even if we don't have a cloud service available there, we can push a lot of that data to these remote locations and to dramatically improve the performance and reduce latency for your customers using those applications. Now, in order to use the CDN, you have to turn on HTTPS load balancing or other network load balancing. But in this case here, you can actually push and publish content directly from Google Cloud Storage to the CDN. But if you want to use it from the network layer, we can automatically start to cache any data that's being that goes through our HTTPS load balancers. So that's a kind of a huge benefit. Another one, it's really affordable. And second, you can actually save 50% egress fees. So normally we charge about I believe it's 9 cents as of this recording, egress for every gigabyte of data that leaves our network. Now, if that data that leaves our network is coming from Cloud CDN or even one of our Cloud CDN providers, that drops down by 50%. So it's a huge advantage to your users, to your apps, and to the bottom line. So there's really no reason why you probably wouldn't want to take advantage of this. So let's move into some other scenarios. What if we want to work with other cloud providers? Well, there's a couple ways to do this, and this also works for on-prem. So here you have your Google Cloud Platform. Looks like I've lost my laser pointer. And then you have another cloud. And whatever you're doing at that cloud, you somehow need these two networks to be interconnected. So you can do this dynamically or statically using Cloud Router, which will allow us to basically advertise and route traffic to whatever subnet range that you have over here. The big thing in the middle is you need to have some kind of dedicated interconnect. So we have what's called a Cloud Partner Interconnect or even dedicated connections, which can connect us to other providers. So in this case here, we can actually have private bandwidth between both cloud providers. And of course, if you have the proper routing between the two, we can route those networks equally between the two different locations. So some customers will, even run some of their production apps. Maybe they were on EC2 for a long period of time. They're taking advantage of their discount contracts, but they'll go ahead and use some of our backend for log processing and other maintenance. And so having this connection between multiple clouds is definitely something worth considering. Now that's a dedicated internet connection. You can also take advantage of VPNs. And so there's a couple ways to do that. So you can aggregate multiple VPN gateways to try to aggregate the bandwidth to your other provider. You can also do this in reverse. And in this case, we usually allow about 1.5 gigabit per VPN tunnel. So this way you can aggregate these together or create a fully meshed network. So this way you have failover in case the remote VPN gateway fails, you have backup links, etc. Just standard networking redundancy built in. And so all this is really available through Cloud Router. Again, either setting static routes or dynamic routes. So if you're making network changes at the other cloud provider and spinning up new subnets that might be custom, you want to make make sure that the Google Cloud Platform also knows about that, and you would take advantage of our cloud routing service to make sure that notifications are possible. So let's talk about performance. With a dedicated link, you're pretty much unsaturated. It's not a shared link. You have a 10 or 100 gig link between providers and or on-premise. What about VPN though? Well, remember, we do kind of have some limitations, and you have the multiple channels, which aren't always going to truly maximize it because it depends on how many streams. But there are many different settings that are covered in the documentation. But a couple things to be mindful of is the AES-GCM. It offers the highest throughput. So if you can choose that encryption protocol, and there are many of them. In fact, what I do find, and I've heard from some of the other customer engineers, a lot of the older protocols either aren't supported or can be also very flaky. So using newer VPN networking gear has always seemed to produce the best results. And so, of course, you can't really do any of this without measurements, and so we recommend that you run iPerf, which will allow you to measure the potential bandwidth between your VPN or any networking tunnels, any networking segments that may be involved in your application.
In this module, you learned about the flow of data through the system, including edge technologies like external IP addresses, Google's Content Delivery Network, or CDN, edge connection technologies, including Virtual Private Networking, or VPN, and third-party ISP dedicated interconnect. You also learned how data can be redirected both at ingress and from within the network using various kinds of load balancing services.